Hello everyone and welcome back. In this lesson, we're going to learn how to simplify radicals using prime factor decomposition. We'll begin with square roots, then move on to cube roots and higher roots, before looking at examples involving variables. By the end of this lesson, you'll be able to apply the same method to any radical. If you're not familiar with prime factor decomposition yet, there's a separate lesson linked in the description below. It explains the method step by step and will make this lesson much easier to follow. The goal of this project is to make maths clear, simple, and easy to understand. Many topics seem difficult at first, but that's often because they haven't been explained in a simple way yet. Once we understand them, they become easy to tackle and even enjoyable. That might sound hard to believe, but let's see if we can prove it. Remember, understanding the method is only the first step. Real progress comes from applying it, so whenever you can, pause the video, have a go yourself, and then we'll work through the solution together. Let's look at the steps we'll follow throughout this lesson. First, we'll use prime factor decomposition. Then we'll look for complete groups of identical factors. Each complete group comes outside the radical. Any remaining factors stay inside the radical. The index of the radical tells us how many identical factors make a complete group. Remember, this method isn't just for simplifying radicals. It also allows us to find the exact value of many roots without using a calculator. Sometimes the radical simplifies to a whole number, and sometimes only part of it simplifies while the rest remains inside the radical. Either way, we'll follow exactly the same method. Let's put these steps into practice with our first example. Simplify the square root of 72. The first step is to use prime factor decomposition. We'll write 72, draw a vertical line, and start dividing by prime numbers. Whenever the number is even, you can always start with 2. Since 72 is even, we'll divide by 2. 72 divided by 2 is 36. 36 is also even, so we divide by 2 again. 36 divided by 2 is 18. 18 is still even, so we divide by 2 once more. 18 divided by 2 is 9. 9 isn't even anymore, but it is divisible by 3. 9 divided by 3 is 3. Finally, 3 divided by 3 is 1. Now let's look at the index of the radical. There isn't an index written, so this is a square root, which means the index is 2. The index tells us how many identical factors make a complete group. Since the index is 2, we're looking for groups of 2 of the same factor. Here we have one complete group of 2's with 1 2 left over. We also have one complete group of 3's. Each complete group comes outside the radical. So this group becomes a single 2 outside the radical. This group becomes a single 3 outside the radical. The remaining 2 doesn't belong to a complete group, so it stays inside the radical. We can now rewrite the expression as 2 multiplied by 3 multiplied by the square root of 2. Now we multiply the numbers outside the radical. 2 multiplied by 3 is 6, so the square root of 72 simplifies to 6 root 2. Now let's apply the same method to another square root. This time, we need to simplify the square root of 108. As before, we'll start with prime factor decomposition. 108 is even, so we divide by 2. This gives us 54. 54 is also even, so we divide by 2 again. This gives us 27. 27 is divisible by 3. 27 divided by 3 is 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. Since the index is 2, we're looking for groups of 2 of the same factor. We have one complete group of 2's and one complete group of 3's. Each complete group gives us one factor outside the radical. There is one 3 left over, so it stays inside the radical. We can therefore rewrite the expression as 2 multiplied by 3 multiplied by the square root of 3. Multiplying the numbers outside the radical gives us 6. So the square root of 108 simplifies to 6 root 3. So far, we've only looked at square roots. Now let's see what changes when we work with a cube root. This time, we need to simplify the cube root of 54. We'll start with prime factor decomposition. 54 is even, so we divide by 2. This gives us 27. 27 is divisible by 3. 27 divided by 3 is 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. Remember, the index of the radical tells us the size of each complete group. This time, the index is 3, so each complete group must contain 3 of the same factor. Here we have one complete group of 3's. The 2 stays on its own, so it remains inside the radical. We can now rewrite the expression as 3 multiplied by the cube root of 2. So the cube root of 54 simplifies to 3, cube root 2. Let's look at another example involving a cube root. This time we need to simplify the cube root of 432. We'll begin by performing the prime factor decomposition of 432. Once we've done that, we can identify the complete groups. To do that, we look at the index of the radical to determine the size of each complete group. The index is 3, so each complete group must contain 3 of the same factor. Here we have one complete group of 2's and one complete group of 3's. Each complete group comes outside the radical. The remaining 2 doesn't belong to a complete group, so it stays inside the radical. We can now rewrite the expression as 2 multiplied by 3 multiplied by the cube root of 2. Multiplying the numbers outside the radical gives us 6. So the cube root of 432 simplifies to 6 cube root 2. We've now seen square roots and cube roots. Let's move on to a fourth root and apply exactly the same method. We need to simplify the fourth root of 96. We'll begin by performing the prime factor decomposition of 96. Once we've done that, we look at the index of the radical to determine the size of each complete group. The index is 4, so each complete group must contain 4 of the same factor. Here we have one complete group of 2's. Each complete group comes outside the radical. The remaining factors 2 and 3 don't belong to a complete group, so they stay inside the radical. We can now rewrite the expression as 2 multiplied by the fourth root of 2 times 3. Multiplying the factors inside the radical gives us the fourth root of 6. So the fourth root of 96 simplifies to 2 fourth root 6. So far, we've only simplified radicals involving numbers. Let's now see how the same method works when variables are involved. This time, we need to simplify the square root of 45, a cubed, b to the power of 6. We'll begin by performing the prime factor decomposition of 45. Once we've done that, we look at the index of the radical to determine the size of each complete group. The index is 2, so each complete group must contain 2 of the same factor. The prime factor decomposition of 45 gives us one complete group of 3's. That complete group comes outside the radical as a single 3, while the remaining 5 stays inside the radical. Now let's look at the variables. We treat variables in exactly the same way as numbers. We can write a cubed as a multiplied by a multiplied by a. Since the index is 2, we can make one complete group of a's, leaving one a inside the radical. We can also write b to the power of 6 as b multiplied by itself a total of 6 times. This gives us 3 complete groups of b's. Each complete group comes outside the radical, and the factors outside the radical are multiplied together to give b cubed. We can now rewrite the expression as 3 times a times b cubed times the square root of 5a. So the square root of 45a cubed b to the power of 6 simplifies to 3a, b cubed square root of 5a. Now it's your turn. Simplify the square root of 288, x to the power of 5, y to the power of 4. Pause the video and have a go before checking the solution. Press play when you're ready. The expression simplifies to 12, x squared, y squared, square root of 2x. And that's it for this lesson. If you found it helpful, please give it a like and consider subscribing to the channel. Thank you for watching, and I'll see you in the next one.